Cloud data security based on Fuzzy Intrusion Detection System with Elliptic Curve Cryptography, ECC, using non-adjacent form, NAF, algorithm. Abstract to secure massive amount of data ranging from highly confidential business, customer data, financial and to fairly unimportant information in cloud environment, either internally or by third parties. We are in need of cloud data protection. This research paper focused on developing a new fuzzy intrusion detection system to handle large flow of data packets in network, analyze them and generate reports by integrating knowledge and behavior analysis to detect intrusions. In addition, to enhance the security of the data stored in cloud, Elliptic Curve Cryptography, ECC, using non-adjacent form, NAF, algorithm is used as encryption techniques to secure data in end-to-end transmission. It increases the confidentiality of the data stored in cloud. So, this paper clarifies how the data is been protected from attackers and a model of algorithm shows how data is encrypted/decrypted. Performance of this proposed system is evaluated with various sizes of text files, on the basis of encryption/decryption processing time and memory. The cloud security levels have also been analyzed and compared with other existing encryption techniques. Keywords: cloud security, intrusion detection system, fuzzy logic, elliptic curve cryptography, ECC, and non-adjacent form, NAF. Introduction. For users, data confidentiality is one of the most prevalent topics in the field of cloud storage. Data stored in a remote server, where the user has no actual control over it and they cannot be able to monitor the behavior of the cloud service provider. 1. The external intruders, or internal service providers, are likely to have a threat and break the confidentiality of the data. The availability of the data is also essential to cloud service provider 2. The data in cloud storage may impose to machine failure, network failure, unauthorized access, or to any internal invasion leads to denial of service, DOS, or distributed denial of service, DDoS, attack to cloud service provider. 11. This paper proposed an intrusion detection system as a strong defensive mechanism to secure cloud data. 3. IDS are used to monitor network activities for detecting known or unknown attacks. The main objective of IDS is to generate alarm if any suspicious activity happens. The proposed system identify break-in attempt from unauthorized user. The cloud security involves various security methods to protect data from unauthorized access or modification. 4. Data encryption is one of the most important factors for improving cloud security, preventing data and tampering data. The data encryption algorithms are broadly classified into two categories: A. Asymmetrical encryption algorithm, public key cryptography, 5. And B. Symmetrical encryption algorithm, private key cryptography, 6. The symmetrical encryption algorithms are RC2, RC4, RC5, DE, 3DES, IDEA, Blowfish and EASE. Asymmetric key encryption algorithms are RSA, Robin, Elgamal and elliptic curve cryptography. This paper proposed a new security mechanism to cloud storage data using intrusion detection system which incorporates elliptic curve cryptography, ECC, for data security and fuzzy rule generation for attack detection. In ECC, data encryption and decryption are carried out using elliptical curve arithmetic mechanism, which based on point multiplication that is performed using repeated point addition and point doubling. In addition, non-adjacent form, NAF, algorithm is used to implement scalar multiplication can speed up encryption process of elliptic curve. The ECC NAF achieves higher performance level in encryption. The proposed system is used to secure data center and cloud service provider being compromised by the attacker. The proposed result can be deployed in platform as a services, PaaS, cloud networking system. Cloud SIM, version 3.1, used for simulation to evaluate rules and to detect intrusion. 2. Related work. Nowadays cloud service provider needs to handle multiple requests from the users and need to process them simultaneously, which makes the processing time high and may lead to data and packet delay or corrupt. The cloud storage system improves the data efficiency but not the data security. In 7. Author proposed intrusion detection system at cloud middleware layer. In cloud environment traditional network IDS are not suitable, since it cannot detect encrypted node communication, also host-based IDS are not able to find hidden attack trail. This architecture of IDS include node to access control policies in middleware, the service to facilitates communication through middleware. An event audit monitor to capture network data, to analyzes which rule/policy is attacked. Finally, the storage holds both the behavioral and knowledge-based database. The author tested the IDS prototype by sending the audit data to IDS Service Core and analyze for attack. The proposed system improves performance satisfaction in real-time cloud environment. though they have not deliberated the security policies compliance check for cloud service provider and their reporting procedures to cloud users. In 8, Ahmed Patel et.al. describe various IDPSs and alarm management techniques by using machine learning classification and evaluate them to detect and prevent intrusions in cloud. The results shows that the proposed CIDS, Cloud-Based Intrusion Detection and Prevention System, improves performance with the help of 4 important parameters like autonomic computing, fuzzy theory, ontology and risk management of the IDPS and cloud computing systems. Revathi, Malathi 9 described cloud data security based on intrusion detection by generation various fuzzy rules to detect alarm. Initially the data stored in cloud environment will be sent to IDS system where numerous fuzzy rules has been generated to check for normal or abnormal data. If the data is from any unauthorized network, the system generate alert to system admin and protect cloud storage from attackers. In addition, once the data has been secured and stored to enhance the confidentiality ease encryption techniques with differential fault analysis, DFA, is used to investigate ciphers and extract keys by generating side-channel attack as a possession of the attacker. The system improves security and confidentiality of the data stored in cloud. In 10 author proposed an encryption technique based on elliptic curve cryptography, to protect information or resource container in the web that are exposed to URL. ECC is one of the small key-sized and fast computation cryptographic model that consumes less power, memory, and bandwidth. The author focused on ECC encryption/decryption techniques to improve confidentiality, integrity, and authentication of the data stored. In ECC, author used elliptical curve arithmetic mechanism based on point multiplication that is performed using repeated point addition and point doubling. The author proposed alternative efficient method for point multiplication is binary form or NAF, non-adjacent form. The computation performance with NAF ensures better optimization than the binary form of scalar multiplication. Mohammed Al-Khatib 12 proposed ECC for binary Edward and Edward curves using non-adjacent form, NAF, as encryption process to perform scalar multiplication. This proposed contribution is used in minimizing the time delay via reducing the number of point addition operations performed during scalar multiplication. In addition, homogeneous projective coordinates were used to avoid time-consuming modular inversion operation. The design is implemented parallelly to accelerate ECC computations and achieve the highest performance level. 3. Proposed system architecture. Data security in cloud environment has been a key point to researcher. Some are focusing on generating better encryption techniques to secure data confidentiality in cloud. The researchers focused on using either asymmetric or symmetric algorithm or a third-party audit to analyze data to ensure with a better encryption, and further some are focusing on remote data integrity. 13. This proposed work is to preserve the cloud storage environment from attackers using IDS security models obtainable with fuzzy logic rule generation for cloud computing. Further, to secure the stored data, elliptic curve cryptography, ECC, is used for encryption based on scalar multiplication with point addition and doubling. To increase the performance of scalar multiplication, non-adjacent form, NAF, algorithm has been used in ECC. The proposed work has been used on Cloud SIM, version 3.0, and can be deployed on any cloud environment. With the rapid flow of data been transmitted to cloud storage environment, may lead to dropping of data packets and also host been compromised by an offending attack. In such situation, the proposed system used a network-based IDS with fuzzy rule generation to monitor alerts to cloud service provider for misconfiguration and intrusion attacks in the system. Further, the improved data confidentiality in cloud ECC NAF encryption techniques is used. Fig 1 shows the flow of proposed system. 4. Proposed methodology. A. Fuzzy rule generation. Fuzzy system is used for modeling uncertainty of natural language and constructing flexible pattern based on rule-based system that can be structured based on prior knowledge. Fuzzy system is based on fuzzy logic, which provides a computational framework for manipulating and reasoning imprecise knowledge. 14. Fuzzy logic increases robustness and learning adaptability of the intrusion detection system. Popular methods used for fuzzy rule generation are decision trees, association rules, artificial neural networks, and evolutionary computation. It is mainly used to separate the normality and abnormality of the connection records in the detection process. 15. Fuzzy logic has been proven to be a powerful tool for decision-making and for handling imprecise and noisy data. The central value of a fuzzy system is defined by the truth value of certain linguistic notions and membership values that lie within the range of 0, 1. In intrusion detection, the security itself includes fuzziness and membership values that lie within the range of 0, 1. The degree of membership of an object takes values between 0 and 1, where 0 means normal data and 1 represent abnormal. The use of fuzziness in representing these numerical attributes helps to smooth the unexpected separation between the normality and abnormality of the data and provides a degree of measure for both scenarios. 14. In this research work, our proposed experimental setup shows the fuzzy rule generation for intrusion detection. Suppose the parameters taken for this example are protocol type, service, source bytes, and destination bytes. If protocol equals TCP. If service equals FTP. If source equals 512 and end source equals 550 and destination equals 512, then transaction type equals probe. The following example explains it briefly. After training with a large number of data, a typical classification rule will look like: Rule 1, if source equals 512 and source equals 550, source equals 4096 and destination 2048 and destination 4096, destination equals 512. This is an example, and some rules are very rarefied as far as understanding them is concerned because the proposed method gives complete freedom to the computer to generate rules to identify/classify an attack. B. Elliptic Curve Cryptography. ECC was proposed by Miller and Koblitz as a reliable and efficient public key crypto system. ECC uses discrete logarithm problem for elliptic curve to develop security in cryptographic algorithm. ECC encrypts a message by converting it into a point on elliptic curve, then applying the scalar multiplication operation on that point to yield another point laying on the elliptic curve. The point obtained after the scalar multiplication represents the encrypted message, which can be converted into a ciphertext as well. 16. The researcher focused on using ECC asymmetric ciphers properties with different security applications, and it proves that ECC achieves high level of security with smaller key size than other algorithms. It shows that ECC can perform security operations such as encryption and decryption with high performance level or speed and consuming less resources, especially in hardware implementations. 17. Basically, ECC performs modular arithmetic operation over finite fields such as binary field, 2m, or prime field GF, p. Encryption is based on scalar multiplication. The two basic scalar operations are point doubling and point addition to obtain ciphertext. 17. The computation form for scalar multiplication is Q equals Kp, where P and Q are the elliptic curve points and K is an integer. This is achieved by repeated point addition and doubling operations. To calculate the above, integer K is represented as K equals Kn1, 2n1 plus Kn22n2 plus K1 plus K0, where Kn1 equals 1 and K 0, 1, I equals 0, 1, 2n1. This method is called binary method. 19, which scan the bits of K either from left to right or right to left. Below algorithm shows the computation of binary method Kp. Algorithm 1, binary method for scalar multiplication. The length of K depends on the cost of multiplication and the number of ones. The number of non-zero digits is called the Hamming weight of scalar. Average, binary method requires n1, doublings and n1/2 additions. For each bit 1, we need to perform elliptic curve doubling ect blue and elliptic curve addition ecod. If the bit is 0, we need only ect blue operation. The speed of scalar multiplication or Hamming weight will improve based on the reduced number of ones. 18. See non-adjacent form, NAF, on ECC. The NAF properties are used in various algorithms, particularly in cryptography, for reducing number of multiplications needed for performing exponentiation by squaring depends on 0 bits. If an exponent digit value is 1, it shows as multiplication by the base, and if its digit value is -1, its reciprocal. In scale multiplication, point addition and point doubling are high-level computations for ECC. Each point doubling and addition includes a number of modular multiplications, modular division, and modular addition operations. The modular division operation is the most time-consuming operation since it requires finding the multiplicative inverse 12. Unlike usual implementations, using the binary method, which assumes that point addition happens half times compared to point doubling, the NAF algorithm's implementation performs point addition 1/3 times compared to point doubling operation. This represents a considerable improvement since it reduces the time consumed by the scalar multiplication operation, and thus the encryption process. 20. The proposed ECC_NAF algorithm performs scalar multiplication for encryption process which minimize time delay based on point addition and doubling. Further, the implementation achieves high performance level in ECC computation. 6. Performance evaluation. This section focused on performance evaluation of the proposed IDS-based cloud environment. It shows how the proposed system handles data packets and the time measurement to detect attack based on encryption/decryption. Additionally, Cloud security measure has also been analyzed and compared with other existing encryption algorithms. Below table1 shows various input file size used for storage. The proposed ECC_NAF has been compared with various advanced encryption standard EASE algorithm and with EASE with differential fault analysis DFA, EASE_DFA, 9. Below Table 2 and Fig 2 shows encryption time for different methods measured in milliseconds. In Fig 4, the average memory usage for ECC_NAF is more due to its scalar multiplication than EASE_DFA. Table V in Fig 5 shows cloud environment security level based on Fuzzy Intrusion Detection System, FIDS, and compared with existing encryption techniques. 7. Conclusion. Cloud environment provides flexible computing resource to its end users and allow to store data, which may lead to security issues. This paper proposed security measures in 2 different modes. Initially it secures by monitoring and protecting the cloud environment from unauthorized users/attackers by using a proposed fuzzy-based intrusion detection system. FIDS traces attackers more efficiently and protect environments significantly. In addition, to protect the stored data in cloud, this paper prosed and tested with new encryption techniques by using ECC along with NAF to increase scalar multiplication time and protect data. The system performances clearly shows that ECC_NAF provides better security and encryption level than existing system. The proposed system also reduces false alarm rate raised by IDS and achieves 90.5% of security level and prevents cloud environment in cost-effective manner.